Welcome to clickmyproject.com. Let's discuss about the product. Our product is frame-based recovery of corrupted video files using video codec specification. Line scratch detection and film scratch detection in old films is a particularly challenging problem due to the variable spatiometer characteristics of this defect. Some of the main problems include sensitivity to noise and textures and false detections due to thin vertical structures belonging to the scene. We propose a robust and automatic algorithm for frame-by-frame line scratch detection in old films, as well as a temporal algorithm for the filtering of false detection. In the frame-by-frame algorithm, we relax some of the hypotheses used in previous algorithms in order to detect a wider variety of scratches. This step's robustness and lack of external parameters is ensured by the combined use of a Cantrop methodology and local statistical estimation. In this manner, over-detection in textured or cluttered area is clearly reduced. The temporal filtering algorithm eliminates false detection due to thin vertical structures by exploiting the coherence of their motion with that the undercycling skin. The experiments demonstrate the ability of the resulting detection procedure to deal with difficult situations, in particularly in the presence of noise textures on slanted or vertical scratches. Comparison shows significant advantages over previous work. The restoration of old films is a subject of primary interest due to the great quantities of old film materials present in film archives. Unfortunately, manual digital restoration is extremely time-consuming and labor-intensive. For instance, the recent restoration of Google's George Mealy's Voyage Dance Alone took 1 year. It is clear, therefore, that automatic or semi-automatic tools designed for the detection and restoration of defects are highly desirable. Some of the most common defects in film scratch include dust or dirt, blotches, flickers on the line scratches. Here we consider the lost defect and the line scratches, usually caused by an absorption to physical film. A good explanation for the physical origins of the line scratches may be found at. These line scratches appear as thin, bright or dark lines which are roughly straight and vertical. These defects also present in a singular characteristic of temporal persistence, meaning that they remain in the same or similar spatial position of the several frames. Consequently, the detection algorithms must be spatial adapted to this defect. However, these characteristics are very variable, making line scratches detection and restoration a particularly difficult challenge. For instance, in some cases, the scratch is semi-transparent, so that some of the original image information is still unavailable. We propose the detection and restoration algorithm for our video input datasets. So we are processing all this process to videos. Our given videos, which is the damaged videos, that means pixel wise. So our process is to recover the pixels which is damaged by the lot of difficulties. So this shows about our flow of our proposed process. So as we already discussed, we are taking the input, that means scratched inputs, that may be a line scratches or any pixel damaged process. So in our input video database, there are a lot of videos which all are based on damaged pixels. So in at least a minimum number of frames are damaged in every video inputs. So for our process, initially we are converting all videos into frames. So that means if I am taking an input, if I am applying a input to the process, means the taken video is splitted into frames. So the taken video can contain up to n number of frames. So depend on the video taken and time duration, up to all frames are converted. That means video to frame conversion. And then the converted frames are done by pre-processing. In pre-processing, filters are used. So by filtering, noises are removed in all frames. And then in the data extraction, this is takes the relevant data to the damaged pixels or the scratches. So and then the relevant data we are processing reconstruction or identification. Let's see the demonstration of our product. Our product is, as we already discussed, our product is based on MATLAB programming language. For that we are using MATLAB tool, that is the version 2013A. So this is the main window of MATLAB. So this is the command window. Here that is a workspace and current directory. In current directory you can see what are the files included in our product. So these all files are included in our product. So this depends on the selected files. The details will be visible here. So we can see there are similar name with different format files are here. So this is called MATLAB main file, and this is the corresponding .figure file that represents the graphic user interface. That means that is the main window of file. So I am selecting main.m and I am running the process. So this is input file selection. So I am inserting input. Here I am selecting Kelvin. This is the input file I am selecting as, and the inputted sorted file will be visible here in the axis or in the movie player. So I have selected the frame as an input. So this is the inserted input. Here I have selected the input and I am extracting frames in the given dataset. So this is the extracted frames. So next we have to process each channel by channel. So initially I am taking original red channel. So and then after that I have to apply this recovery process to the red channel alone. So that will process for red channel. So similarly we have to process for all remaining two channels. That means red channel, green channel and blue channel. Those are red channel, green channel, blue channel. Those are processing separately. And then the recovered frame will be here. So and then I am going to reconstruct all the three channels here. All the channels are reconstructing here. So and then converting into video. So this process converts that into video. Thank you.